This is a quick demonstration of an experimental Lua script called copter-deadreckon-home. As you might imagine from the name, the purpose of the script is to deal with short-term GPS failures or EKF failsafes, especially if the vehicle is in autonomous mode like auto mode or guided mode and it's beyond the line of sight. So to get things started, I'll just switch it into auto mode and off it goes. You can see it's climbing here. Now there's a little message here, DR. This is from the Dead Reckoning script, and it's waiting for the vehicle to get to be at least 50 meters from home. So it's finally climbed to 30 meters, and now it is heading towards waypoint 1, and we can see there it is, it's just become enabled. So now, at any moment, I can disable the GPS in the simulator. Like this. It's disabled. You get a little message saying that GPS or EKF is bad. The vehicle is now switched into guided no GPS mode. It's turned around and it is now flying home, or it's flying in the last known direction of home at a lean angle of 10 degrees. You also see that it's climbing slightly. That's because I've set a minimum altitude. There's a number of parameters that I'll go over in a minute. I set the minimum altitude to 50 meters. So it's climbing up to 50 meters on its way home. And then if I re-enable the GPS to sort of simulate the GPS returning to normal, you can see we get this little message, GPS and EKF recovered, and the vehicle is now in RTL mode, and it should land safely. Okay, so let me just quickly go over some of the parameters that are available. There's this parameter called DR enable. That's just to enable or disable the script. Set it to 1 to enable. The DR enable dist. This is the distance that the vehicle must be from home for the script to become enabled for the first time. This DR fly alt min. This is the altitude that the vehicle will fly at on its way home. So this is an altitude above home. Next is the DR fly angle. I've got it set to 10 here, so that means the vehicle will face home and then pitch forward at 10 degrees. There's also this DR next mode. This means that this is the mode number that it will switch to when the GPS and EKF recover. So 6 is RTL. You can set it to any mode you want. If you set it to -1, then it will actually return to the mode that it was in when Dead Reckoning took over. In general, I recommend sticking with 6 for RTL. Okay, next we've got a couple of parameters here for adjusting the sensitivity to GPS failures. So DR GPS speed accuracy max. So this means that the speed accuracy must climb above 0.8. A normal value when you're flying is about 0.3 or so. So 0.8 means that the speed accuracy has gotten worse. Next is the sat min. This is the number of satellites. So 9 means that yes, obviously the number of satellites will have to drop below 9 for it to trigger. It's actually an OR case, so if either one of these happens, it will trigger. The GPS trig sec is not very important. It just means that after the GPS quality degrades, it has to continue in that degraded state for 3 seconds before it will try to take over in Dead Reckoning mode. Then finally, there's this DR fly timeout. So once it begins Dead Reckoning, it starts a counter or a timer. And so in this case, after 60 seconds, it will try to switch to next mode. So whichever comes first. If the GPS and EKF recover, then it'll switch to next mode. If not, once this timeout expires, it will try and switch to next mode. Now, if it can't switch to next mode, say for example, this is set to RTL, but the GPS and EKF haven't recovered yet, so it can't get back into RTL mode, well, it will just keep on trying. So it may just keep on flying in this no guided GPS mode until the GPS recovers. Okay, that's it.